In this video, we're going to learn how to use the JackBord RGB color sensor. If you haven't already viewed part 1, it's a good idea that you do so. You can jump to the part 1 video directly by going to www.jackbord.org and at the search prompt enter the TMT code TMT3NNDU and press enter. This will take you directly to the part 1 video. You can jump directly to the sensor's homepage on the JackBord website by going to www.jackbord.org and entering the TMT code shown on the screen in the search prompt, and this will take you to the sensor's homepage. In part 1, we connected the sensor to the port D port of the JackBord, as shown in the photograph. If you haven't already done this, go back to the part 1 video and find out how. To start using the sensor, the first thing we need to do is turn on the JackBord's I2C system, which is used to communicate with the sensor. To do this, go to the command page and type I2CON and press enter. The JackBord will look for the I2C devices and tell you that it's found the RGB color sensor. This means that the color sensor has been detected and we can now use it. To make using the sensor easy, Octagon has all the variables you need built in. That way you can start using it in your program straight away. These variables are called system variables because the user doesn't create them and they always exist. And the ones for the RGB color sensor all start with CS underscore, where the CS means color sensor. The first variable is the clear variable, and this is the white light value coming from the sensor. Next, we have the red value, which is the value from the red sensor. Likewise, the green value for the green sensor, and the blue value for the blue sensor. These sensor values, red, green, and blue, have a range from 0, which means completely dark, to 255, which is the maximum value you can get for any of the colors. The simplest way to get the colors from the sensor is to use the command line. So on the command line, type this command, jp space quote red space / cs underscore red end quote, and press enter. This displays the red value, which in our case is 86. This is the amount of red light currently being detected by the sensor. Now, place a red object under the sensor and use the up arrow on your keyboard to bring back the command we just ran. Then press enter. In our case, we got a value of 103. This is the increased value because of the fact that we put something red under the sensor, and therefore it's picking up more red light. To get the readings for all of the colors, type this command at the command line and then run it. In this case, red is 81, green is 86, blue is 75, and clear is 44. If I place a green object under the sensor and run the command again, we can see that the green value has increased from 86 to 110. And likewise, if I place a blue object under the sensor and rerun the command, the blue value has increased from 49 to 99. Now it's time we start using the color sensor with a program. To do this, click on the prog page link in the dashboard. Once you arrive at the program page, choose a slot in which you don't mind losing the program. Then select all of the code in the program and delete it. Click the Ref tab, and when you get there, at the search prompt at the top, enter the TMT code shown on the screen. This will take you directly to the RGB color sensor Demo 1 program. Once there, select all of the code and copy it. Then put your cursor in the program window on the left and paste the code. Next, save the code by clicking on the disk. Then click on the Print tab so that we can see the output of the program when we run it. And finally, to run it, click on the aeroplane. This program will display raw readings from the RGB color sensor. So if I place something red under the sensor, the red values will increase. And likewise, if I place something green under the sensor, the green values will increase. And finally, if I place a blue element under the sensor, the blue value will increase. This simple program shows the values from the sensor in terms of text. In the next example, we're going to use a graphical program to display the raw readings from the sensor. To run the Demo 2 program, go to the Reference tab and at the search prompt type TMT 3 capital N small n DW and press Enter. This will take you to the Demo 2 program. Once there, select all of the code, copy it, select all of the code in the left-hand window and delete it, and then paste the new code in and save it. To run the Demo 2 program, click on the Show tab and then click on the jet plane to run the program. The program will display a series of bar graphs that indicate the value from each of the color sensors. So now if I place a red object under the color sensor, the red bar increases because we're getting more red light into the sensor. Likewise, if I place a green color under the sensor, the green bar increases. And finally, if I place a yellow object under the sensor, both the green and the red values increase together because the color yellow is made from red and green. The sensor's LED light is located right next to the sensor itself, and in our case, it's controlled by port pin D1. If I want to turn it on, I need to turn on port pin D1, and when I do this, the light turns on. And likewise, to turn it off, we turn port D1 off. There are some instances in which you need the light because the ambient light isn't good enough for detecting colors. In these cases, you turn on the sensor's own light. To summarize, the RGB color sensor is used to detect different colors by using a red, green, and a blue color sensor in an integrated circuit. You can access the color values from the sensor using the system variables in the Octagon programming language. To get to the sensor's home page, go to www.jackbord.org and at the search prompt, type the TMT code shown on your screen. This will take you directly to the RGB color sensor's home page. Here you can find more information about the sensor, including more programs and projects. In the meantime, if you want any other information or are just curious, you can visit us on www.jackbord.org.